All right, welcome back. By now, you should have received um, some of the things like your book and your shirt. Um, so there we go. Let's go ahead and I still have a lot of things that I want to talk about. Um, and what I'd like to do is jump right in and talk more from an operational view on some of the things that you're going to see on your exam. So let's jump in and talk about identity management. So really, to me, one of the best stories that they outline in the book, and you may have heard of this in the past. So there's a story about four blind men who are trying to describe an elephant. One blind man feels the tail and announces it's a tail. Another blind man feels the trunk and announces it's a trunk. Another announces it's a leg, and another announces it's an ear. This is because each of those blind men can't see or comprehend the whole of the larger creature, just a piece that they are familiar with and that they know about. So this is an analogy of how identity management is because of the scale and the gravity of everything that it touches within the organization. It's massive within enterprise and within the enterprise, and it has so many tentacles, like I was saying, so many different components that a lot of people don't understand exactly what the whole of the identity management implementation is. They only understand what they see through their little knot hole. And maybe they're an expert in that, and they're definitely, something that we need. But to take an operational view and understand from a holistic perspective of what is going on in that regard is what I'm going to try to do right now. So we try to implement identity management in a way that we can bring together all these different products and have a centralized repository for them. So I remember when I was at NASA, one of the projects that I came on to assist with as a subject matter expert in identity management was to implement the personal identification verification at NASA. So their form of a CAC card, they call a PIV card. And at that time, we had a lot of disparate systems that were not using a centralized repository for single sign-on. They were using their own authentication mechanisms all around the agency. So here at the Marshall Space Flight Center, we took on a agency-wide project where we had we had the 16 centers that would consume our identity management solution. And because of that, what we did is we had close to 700 different applications within the agency that ended up having to change the way their model was to begin to authenticate using our methods as a more holistic approach to centralizing security, centralizing access control, centralizing provisioning of accounts, and making sure that we had control over who had access to what, and we were being able to audit all of that information as well. And so in that regard, being able to implement things like account management, access control, end user password self reset is a big deal. Of course, single sign on technology and being able to provision different rights through workflows and permissions of those user accounts. And all the while keeping track of everything through change management of integrating or hooking into workflow engines like Remedy or Jira or Vantiv. To be able to have that accountability is of utmost importance. And so I bring in to the fold now a way that hopefully we can start to make sense and look at the elephant as a whole instead of the little tiny pockets that each one of us may be more familiar with in our careers. And it really all starts with what's called the X500 standard. So anytime we want to talk to a directory, whether that's a traditional LDAP directory or directory services, a Novell directory, an Apple directory, or most common, the Microsoft Active Directory, we want to be able to use a uniform way across the land that says that it is, in fact, a directory server. And so a directory server, when I was first getting into the business on directory servers, the way that it was explained to me was that a directory server is kind of like the old school white pages. If you're not familiar with the white pages, I remember growing up, we would get that massive, huge book, probably double the size of the CISSP, and it would just get thrown on your driveway. The white pages, not the yellow pages, the white pages. And in the white pages would be a listing of everybody within your geo community. So maybe your zip code or your area code or both. And from that, you could, by last name, it was organized, you could look up by last name whose phone number that you wanted to potentially call. And so the metaphor, if you will, or the paradigm to equate what a directory server is, it's kind of like the white pages, where essential information about an identity is stored, and it has very fast lookup speeds, so it can be authenticated very quickly. And I say that because those white pages, I remember very fondly in middle school and even early years in high school, for me at least, that if there was a girl that I was interested in talking to on the phone, what I would do is I would just look up the last name, see if I could find out, how many of those last names there were. Hopefully it wasn't Smith or Johnson or something like that. And basically what I would do is, and I'm self-incriminating, I'm throwing myself under the bus. What I would do is I would pick up the phone and call. And if I heard her, I probably would have hung up at that time because I was so scared. But eventually I would get enough courage and be able to find them very quickly that I could dial the number, figure out it was them, and then talk to them accordingly. And so, I mentioned earlier about these different rules or protocols that we follow or that are set across the land for ways that we communicate on networks like TCP and IP and the OSI model and things like that. And I think about it in the same sense here, that the X500 and specifically being able to communicate over LDAP is how we can talk to directory servers. So if you know how to write a query in LDAP format, it's very likely that any directory that's out there, it doesn't matter if you're here in the United States or anywhere in the world, if it speaks directory services and you know LDAP, you can talk to that directory server. And so it's organized in a hierarchical model, in a way that the domain is at the top and it's broken into organizational units. So that's something that we're going to jump into here, and I want to talk about organizational units. So these organizational units, or OU is what they're called, is how we can basically put people into these different groups, these different organizational units, that allows us to very, very quickly look up their identity to make a decision on access control. So keep that in mind as you're going through and taking a look at this. One of the pictures in the book that I think is very good in the Sean Harris book is this one right here. So the directory hierarchy that typically we see is, in this case, there's a directory schema, the X500 schema. Remember, that's what we just talked about. This is the X500 schema, and it's organized in a way that's meaningful and that makes sense. And it's a reverse lookup a lot of times. And what do I mean by that? Well, if I'm going to go and look for a person, and in this case right here, this person down here, Kathy Conlon, that's who I'm going to look up. If I'm going to go look her up, what I need to do is I need to do an LDAP query to look her up. Now, Ben McGee, the average user, wouldn't just type in and do an LDAP query. First off, I wouldn't have access to it to be able to do it, hopefully. And secondly, typical people don't know how to just look it up. So when would that be used is the question. And to answer that, typically what we do is in programs that are trying to communicate with the directory, what we'll typically do is we will program them to communicate using the LDAP query lookup in a reverse attribute format. So we can go and access that object. So in Kathy Conlon's scenario here, my reverse lookup for an LDAP query would be something like this right here. So my query, I would start to build it out. It would be organizational unit of general. You can see the general down here, right? And then the organizational unit of equal to NCTSW. And then my organizational unit of, and remember I said TSW, not TSQ, right? So it would be reverse, right? It's going to be OU is equal to general. And then OU is equal to NCTSW. Nope, I did it again. TSQ. And then OU, again, these are, OU stands for organizational units, not the University of Oklahoma or Oklahoma University. WNU. And then it's doing a reverse lookup to, now I'm at locations. And I'm basically going up the stack here to the next one. OU would be, in this case, equal to Navy. And then I move up to OU is equal to the DoD. And then the OU would be, in the next case, the U.S. government. And usually we probably would not put periods in there because that might mess us up just from programming standpoint. And then finally, the domain or the country that we're in would be the U.S. And so this specific object that I'm looking for is in the general OU, in the NCTSW organizational unit, all the way down the food chain right there. Now, there may be 10 different records in this one organizational unit. And for this particular purposes here, what we might see is this thing that's called a distinguished name. So this distinguished name, or DN, is how we can uniquely identify a user in the directory. So in addition to what you see that I just wrote up here as the LDAP lookup, I would also here at the front end of this, I would put DN equals Kathy Conlon. And then now that query would bring back her object for me to consume as a program. So if I'm interfacing with the directory server, and let's say I want to check credentials for Kathy Conlon, now I bring back the object in an application that I'm writing. So a piece of software, I bring back the object from the directory. Now I have access to everything that's associated with that directory object, in this case, Kathy Conlon, where I can take the identity and I can take the password and see if I can get that one-to-one verification and authenticate that person. And so typically the directory hierarchy is put into this X500 schema and utilized in this way. Now, this may look very similar to something that we talked about before and in cryptography, and that's the X509. If you recall, X509 is primarily for implementing PKCS number 11 and primarily for implementing PKI. So why do I mention that right here? Well, guess what? A lot of times we don't want to reinvent the wheel. And so what we will do is we will create something. If it works, then we want to reutilize it again and over and over and over again. Well, if I was to come in here and erase this, the X500, right here, check this out. I'm going to do a little magic trick here. If I go, boom, erase that, and then now I come back and I say, what does the X509 look like? Well, guess what? X509 uses the same directory schema to store certificates. So usually best practice is that we would have two instances. We would have the primary Active Directory, and then we would have the X509 digital certificate directory server or PKI server as a separate entity altogether, separate server, separate implementation, but they both would share a common schema. So the organization that we have here with this X500 schema can be exported and then imported into an X509 that would allow anyone that is in a position of public trust or a program that has the ability to do it would allow a lookup from the X500 to the X509. So they're tightly coupled using, here's the key word here, metadata. And so remember, that's data about data. So the linking between the two is going to be the distinguished name, and the directory server will have, you know, the basic identity information, your surname, your first name, your last name, the where your office is, things that you typically will see in the global address list will be in the directory server. And then the directory server will create a metadata tag, essentially a pointer that says, hey, we're implementing PKI, and the pointer for that PKI is this right here. I'm connecting it to you via metadata. And so now those two servers can talk back and forth, and you're able to utilize not only the directory server, but the PKI server based off of that LDAP lookup, even though they're two separate entities that require two separate kinds of access. The way that they're organized, the schema that they're organized is white pages like in a X500 schema hierarchical model that is organized in these things called organizational units and tied back to a distinguished name, a unique identifier for a specific person. So that's important because we want to know who the identity is tied to, how can we authenticate that person, three forms of authentication: something you know, something you have, something you are, typically is what we refer to, something you know, something you have, something you are. Or another way to think about it, which is kind of a little bit more fun way to think about it, is something you can forget, something you can lose, and something you can get cut off. Right? So it's something you know, something you have, something you are, or if you want to remember it a different way, something you can lose, something you can forget, or something you can get cut off in the biometric sense in that regard. So think about that. And some of the different protocols that we'll use for authentication are shown down here as well. And we'll talk about those momentarily. But for identification and authentication, that's just some of the basic. Any two of those, any two are multi-factor. So, we mentioned a little bit earlier about two-factor authentication. Any two of these put together, so it doesn't matter which two, any two of them that are put together, those would be considered strong authentication. So if you hear the word or words, quote unquote, strong authentication, that's two or more forms of authentication that is implemented for a particular organization. So there's a lot of different things that evolves around an identity. And, for me, I kind of make fun of it here is basically what is not considered an identity. I would argue that our phones or our phone numbers are identities because it can tell us, where we've been, what time we were there, what did we do today, and essentially gives people either a good alibi or a bad alibi to show evidence of that. So a lot of times we're seeing identities and the identity management components show up in the court of law because there's such rigor with the accountability and the auditability of these that you can show when people authenticated, when people were authorized to do certain things, when people sent text messages or other things, including but not limited to buying gas and going to your favorite store or whatever. And so there's a lot of evidence that's out there that is latent to most people. They don't see it or don't even think about it, but it is available most of the time. And one of the questions that you can think about here is how would you convince someone that you were at a location at a certain time? Well, what do? We trust but verify here. Can you give a false alibi anymore? Well, if you don't have a cell phone, you might be able to. But if you're carrying a cell phone and it is on, there's a good chance that even if you have location off, it could potentially give you up as a key piece of evidence, and any digital evidence that is associated with it could also see if you are telling the truth. So keep that in mind. Again, we talk a lot about this, the IAAA here. A lot of times we see auditing and accounting used interchangeably. But one of the things that we utilize for identification is biometrics. And with biometrics, there's a lot of different types of biometrics that are really, really neat. And for the purposes of the exam, I would encourage you to focus on a couple of these. One of them is the retina scan. The retina scan typically is some of the questions that we typically will see in or around the retina scan is that it is the blood vessels. It looks at the blood vessels in the back of the eye. Well, why do I bring that up? Because a lot of times when people start talking about some of the biometrics, they talk about an invasion of privacy and the ability for whoever's implementing the access control system that uses biometrics to potentially be an invasion of privacy. And there's one that usually rears its ugly head on the exam, and that's retina, that typically will ask you different questions. Well, one of the things that retina scans can tell is if somebody has a blood disorder, or maybe if somebody is pregnant or has some sort of illness. You can look at the retina in the back of the eye, and based off of how those blood vessels look, determine a health incident or healthcare incident with them, or an issue potentially with their healthcare. So some people cry out that many of these, not just the retina scan, but many of these are in fact an invasion of privacy. One of them that's kind of interesting is that a lot of times in crowds now, we're seeing a facial recognition or facial scan. We've seen Facebook and Instagram, as well as Snapchat and a lot of social media sites, acquire companies that have some sort of awesome facial recognition and integrated into those social media giant websites. So we're seeing more and more sophistication with biometrics. And one thing reigns supreme is it is still very, very, very expensive to implement. Very expensive to implement. One thing to think about here is with biometrics, we typically will grade the biometrics by a few different errors. And let's talk about these quickly, because the type 1 error that we typically see is called a false rejection rate. And that's okay. Type 1 errors, it's kind of a pain, because you think to yourself, well, why is it rejecting me? But from a system standpoint, you're erring on the side of caution here, where if anything wrong with it, you're going to reject it. So type 1 errors are okay, whereas type 2 errors are devastating to the system. And these are, in a very simple approach, these are not okay. These are not okay, the type 2 errors. Why do I say that? Well, if you're trying to authenticate to a system and the system falsely accepts you, we got problems, Pookie. We got big time problems. So that's not okay to falsely accept a biometric authentication. That is a no-no. And so when a biometric system rejects an authorized individual, it's called a type 1 error, or a false rejection rate, an FRR. When the system accepts an imposter who could be rejected or should be rejected, it's called a type 2 error, or a false acceptance rate. The goal is for a biometric system to obtain as low numbers for each of the errors as possible, but the type 2 errors are the most dangerous and the most important to avoid if possible. So how do we know, and how do we judge a system, a biometric system, for that? Well, one of the metrics that's collected is this crossover error rate. And usually what we'll see with the crossover error rate is it'll be on some sort of diagram, and it will usually show the testing from the system, where over here you have the false rejection rate, the FRR. Over here you have the false acceptance rate of FAR, and where they meet here, the plot at which they meet is going to be the crossover error rate. And usually we want that to be as low as possible. So let's say that we draw a couple of tally marks on here for that. If a crossover error rate was 3 and that system was down here, and we evaluated that system down here, and then a crossover error rate of a system was 4, then the lower the crossover error rate would be, the more reliable that system would be for us to potentially buy or acquire and then implement. Let me give you an example. So when I was working at NASA, we did a bake-off, or what's called a bake-off, for biometric systems, so we could capture fingerprints, so slaps and rolls. And so at the office that that my team worked at, over on the Arsenal, on the NASA side of the Arsenal, we had a lot of different tools that we were evaluating during the project initiation, getting into the preliminary design review, getting into the critical design review. We had a bake-off to see which vendor out there had the most reliable tools for biometrics. And so what we would do is we would take it from the biometrics books, what's best practice, and we put it to a bake-off. We said type 1 errors, type 2 errors, and the crossover error rate. One of the interesting things that, just from practicing implementation and management of biometrics, that we found out is people that worked with their hands, so like, you know, roofers or lawn maintenance folks, or even scientists that were gardeners, or people that would wash dishes a lot, things that you're doing with your hands, where you're doing manual labor perhaps. What we found is that those types of people had more false rejection rates, because the system, what was on file, wouldn't match what they were presenting for identification and authentication. So we couldn't get that one-to-one verification that I talked about earlier with high reliability for some of those people that worked with their hands. And sometimes, some of those maintenance people that would be working outside would cut a finger, like the index finger, let's say. And if they cut the finger and they went to authenticate with their that was the primary finger they would cut, or they would authenticate with, if there was a cut now on there, it would not match. And so we had to think about ways or alternatives to be able to allow those people to authenticate to the system. So around that time, I was working out regularly, and at lunchtime, what I would do is right down the street from where our NASA office was the NASA gym. And so what I would do is at lunchtime, I would go down and play basketball at lunchtime. And, depending on how, just kind of a pickup game with, there'd be 15, 20 dudes out there running two courts indoors on wooden courts, a pretty nice facility. Depending on how my team did, I would play anywhere from 30 minutes up to, an hour and a half at lunchtime. And, I as we were starting to get deeper into this project with the biometrics, one thing that I found was, for myself, when I would come back from lunch, a lot of times I would get a higher false rejection rate for any of the systems that I would be testing. And so I hit up one of the vendors, and I said, hey, in the mornings I always have high success authenticating, and it's reliable. That one-to-one verification, it's very reliable, high success. But then, when I come back from lunch, it seems to not work. I said, what's going on? And the dude immediately said, well, what are you doing at lunchtime? And I was like, well, I'm going down and playing basketball. And what he told me, this expert in implementing identities systems, it was called, is he said that a lot of times people that exercise or even have an elevated heart rate will lead to a false rejection on a biometric system. And one of the solutions for that, because a lot of times when you're perspirating, it gets onto the capillaries or the little tiny places that will sweat on your fingers, and there'll be too much liquid for the sensor to give you that one-to-one match. And what the solution that they found worked was kind of a caveman approach or caveman solution to people that exercise at lunch or even in the morning that come in that are still have an elevated heart rate, maybe still perspiring a little bit, is that you take the hand that you're getting ready to authenticate and you rub it through your hair to get oil from the hair on your hand to then now the minutia that are in the fingerprint would be able to stick to the oil in your hair and be able to give you a higher success rate for authentication. And so I started to do that, and sure enough, it worked with very, very good regularity. And it was just kind of fascinating, some of the things you learn. One other thing that we learned is that anytime that a smoker would go out and suck down a cigarette in 2 or 3 minutes, just kind of chain it, and it's super, super quick, they would come back in buzzing like a bumblebee, and their heart rate would go down a little bit. Some of these biometric systems would check out a baseline heart rate and compare it to your heart rate when you tried to authenticate. And if it was outside of a standard deviation, it would reject you because of that. And so sometimes the smokers would have a false rejection rate as well. There were some of the systems that we evaluated that, let's say that we evaluated 10 of them, and I'm not going to give you the exact number, but let's say we evaluated 10 systems, and out of those systems, we did have 3 or 4 that had one false acceptance rate. And so when we were doing the select down process for that, immediately one of the things that kind of floats to the top is that false acceptance rate. And those 3 or 4 vendors that had that one issue, which whatever the issue is, we don't care. You had a false acceptance where you let something happen that shouldn't have happened. We ended up dropping that particular system from the selection process. So, that one particular incident, that false acceptance that they had, ended up disqualifying them completely from a massive contract with NASA. So keep that in mind as well. So these things are for real. And when we talk about biometrics, there's a good chance that not only will you have at least one question, probably 2, on these right here, type 1, type 2, and crossover error rate. Not only will you have one question on this, but you're going to probably have one question on one of these types of biometric techniques as well. So hopefully you can look forward to that, and anything that you have deficiencies in, you can go and make a note card or some other way that you can try to bring up that deficiency so you can hopefully do better on the exam. So it's been a little while since I did that, and I'm going to have to look that up to see what's that x-axis, because that looks a little goofy the way I drew it there. But essentially, this is the outcome of, usually what you'll see is kind of like it'll be an X, and right in the middle will be the crossover error rate for that. That's usually what we see.
I have a question for that.
What's that?
I also have a question for that.
Yeah, go ahead.
If the x-axis would be how forgiving the scanner is for matches. I think that makes sense. But what is the why is that crossover point special? Is that where we're supposed to try and put the sensitivity?
No. So so let's go back here for a second. So with this, as they're being tested, the number of times that it's tested will typically cause the curve to go up of some kind, or go to the right. And as the events happen, like if there is a false rejection rate, then it causes the line to start to move up, right? Whereas the same thing goes with the false acceptance rate. If the false acceptance rate is way over here, then you could deduce that this system isn't as reliable as this system right here.
Okay.
This is kind of a mediocre system right here. This one is not reliable based off of, the number of false acceptance rates. This one has a low false acceptance rate, so the crossover error rate would then go down if you have a low number of both of these types of errors that are out there. Where, the type 1 error is okay, it's kind of pesky, to reject something. It'd be like, you type it in your password and it's the right password, yet you get rejected with it. It's just kind of irritating. But eventually it'll let you in. Whereas if you type in the wrong password and you're able to get in, there's a bigger problem there. And that's the false acceptance rate. All right. So what I want to do is I want to jump in and talk a little bit about Kerberos here. And if you've not heard of this before, then maybe you are thinking of the three-headed dog gatekeeper to the Greek underworld. But maybe you're not, and you're thinking about how Microsoft, back when they created the new technology, the NT environment, with Windows 2000, so a long time ago now, Microsoft created this new technology that implemented this game-changing new technology paradigm that allowed you to, with Windows Server, now you could create domains. You could create your own domain inside of your corporation. And so you could have numbers of computers or objects that would be able to join the domain. And from there, Microsoft implemented, as well as some other vendors now have it, but Microsoft is the most widely used implementation of the Kerberos. And Microsoft implemented the Kerberos for the single sign-on. And with single sign-on, usually what we see is some sort of ticket that's associated with an authenticated identity. And so Kerberos is built into the authentication mechanisms within a single sign-on infrastructure like Microsoft products, or in a domain specifically is what I'm talking about. So let's give an example. When you authenticate to a domain, the domain controller is running Active Directory. The Active Directory is kind of like the white pages I mentioned. It'll go and do a lookup, see if you provided the correct credentials. Do we have a one-to-one match? If so, then let's authenticate that person. And oh, by the way, we're going to also give you some information on what they're authorized to see. In the form of Microsoft, what that is a ticket. And so this is something latent that you don't see. But what ends up happening is when you authenticate, and then let's say, a minute later, you re-authenticate back to the system behind the scenes, and then another minute later, you're keeping it alive, keeping it alive, keeping it alive, keeping it alive. You don't have to actually do anything behind the scenes. If you're sniffing network traffic, you see the SNMP traffic that's going on, or you see other types of traffic that is handling such requests. And behind the scenes, what's happening is the keep alive, and the ticket is being regenerated with the timing or the expiry period for that session for that individual. And so with the domain implementation and the single sign-on, if there are shared resources on a network, like a network file share, or maybe SharePoint, or an intranet, a company intranet, or email, Outlook, or you name it. You put whatever in there. If you use Teams, Microsoft Teams, or things like Office 365. If you log on to the domain, you authenticate to the domain, you don't have to log into all those other products anymore. Everything is handled for you by the behind the scenes implementation of the domain and the Active Directory using Kerberos as the authentication component. And what ends up happening is Kerberos has a built-in key distribution center, and the key distribution center will allow you to submit a request for a ticket, and based off of your credentials, the key distribution center will either assign you a ticket or deny you a ticket. So for Kerberos, you need to remember single sign-on and tickets. Tickets, please, tickets. And with Kerberos, we have the key distribution center. Key distribution center, which is it is part of built into Active Directory and holds the users and services secret keys that are allowed to be brought to life with the single sign-on process and distributed through a ticket using that key distribution center. It's really a fantastic concept that now nobody even really recognizes how much is going on behind the scenes. But having something like this, where you don't have to re-type in your password and username, for 100 different times each time you're trying to access a different resource, this is absolutely phenomenal.